symbol. I try to reserve the transfer function method here at the same. So I will try to calculate using the Z uniform for
Yep.
calculating the random. Yeah, and if it's less than the defect rate which I declare here,
Yep.
and it's gonna be transferred to the defect, and otherwise it's gonna call the transfer one in here. So in
Okay.
the single rock here, I uh, I assign the QC for the exit method here. So
Yep.
basically, yeah. So when I try to run the simulation with the, we can see that it go there.
Yep. Yep.
Yeah,
Correct.
but
Yep.
yeah.
The
So
call,
in
the actual trigger of the function logic might a little bit different. So you trigger the general query first, and then if the
yes,
query check correct, and then you trigger the transfer, move to there or that. Yeah, it's also this. Yeah, so it means
yeah,
that the attribute you check first is the defect, and then the name to sorting the name. Okay,
yes, that's
you
correct.
use the meter form uniform to classify, and then in my way, so I check the name, and then I check the different attribute. Yeah, it's also correct. Yeah, thank you, Mr.
Yeah,
Phung.
yeah. Thank you.
Any
Yeah,
other?
and I also have one question. Is that is there any other way that we actually uh like we can manipulate the creation ratio of the MU here? Like in your way, there is guarantee that every 10 part there is one part that is defect, right? So it's a, but that is like we are not guaranteed that every 10 part we have one defect part. So that, yeah, so that is just purely randomness. So if we grade that way, we will affect our result in the simulation, because in the reality, uh, there's the case that not always for every 10 part it's gonna create a defect part.
Yeah, correct.
Yeah.
So it means that in the statistics point of view, so it's not
Yeah.
like in the sequence. So it's random in 10. Does it mean
Yes.
that in 10 product, so maybe you will have the defect in the second product, and then in the next 10 slot, and then you have the defect in the product number 8, and then
Yeah.
in the next 10 slot batch, and then you
Yeah.
have the defect in the product number 5. Not
Yes,
like
that's
a
correct.
sequence. It means that 1, 2, 3, 4, 5 until 9 is good, and then 10 is defect, and then in the next 20 is defect, and then in the next 13 is defect. So this is the behavior of Mr. Bao. It means that he will have the defect every time at the product number
Fix for this. Yeah.
10, 11, 20, and so on. So it means that 10 good and then have one bad, 10 good and then have not 10, 9 good and one bad, one 9 good and one bad. So this is a behavior of Mr. Bao. Yes, it's not exactly the same as the reality. Yeah, this is a good example how to show the level of detail. But at the end, what I point out here is 10% of defect rate. So it means that from the uh, challenge that I give, Mr. Bao is correct, but from how close to the reality. Yes, of course, Mr. Phong, and maybe in my solution where I have the random
Yeah.
reaction, the reaction of my MU is random, not in sequence anymore.
Yeah.
So remember, so it's more or less clear to close near to the reality. But again, Mr. Bao have the sequence or our solution in the neighbor will have the closer to the reality. But at the end, what we have is again 10% of defect rate. Remember when I check here, so rather than
Yeah.
using the sequence, I do it
Yeah.
random. Okay, and then it will capture the behavior that you don't have the same sequence of defect happen. Okay, but if in the maybe in the reality you will have the same defect happen. For example, when you wear out of the dies, and then you will have the defect every 10 or every 1,000 of product. There may be good to also know the solution of Mr. Bao, or we can have such kind of other solution. So I can give you another approach. For example, we can create a defect counter here. Okay, so I say counter. We will no, or maybe let's say defect. Okay, 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 is equal to 0, and then whenever. So after you classify, okay, you will do the counter here, window, vertical. Don't use it anymore. Don't use this one vertically. Window, vertically. Yep. So now put it back to the reverse approach that we have. Okay. And then what is it? We don't have this one. We don't have this one. Okay. That's yep. And then here at the end, we just put it back to normal. Oh, just set it like that for now. And then after going out from the single rock, maybe here we can say defect count equal to itself plus 1. Then check if the defect count is greater than 10. Okay. And then I will set the attribute. Okay. Add dot defect. Okay. Equal. It's been set value. It's been double dot equal to true. Okay. Else add dot defect double dot equal to false. And so it means the sorting is still the same, but then whenever one product going now, it will start counting. Okay. It increase this number. So if it's greater than 10, it will set the defect into true. And maybe now we need to set back the counter to 1, to 1 or 0 equal to 0. Okay. So this means that we have a counter. So for every 10 product that you reject 1. Okay. So now this is exactly 10 product, no, exactly 9 product, and then 1 is bad. Exactly 9 product, 1 is bad. Okay. So this is how you do the, not randomly, but I mean that in the reality, maybe we will have such kind of behavior that you have the machine. So after 9 product, it wear out some of the material, or the fixture is wear out, and then you have the incorrect, and then you need to replace the fixture or replace the tool tip. And then it happens for every 10 product or 10 times that you perform the process. And this is how that you capture the behavior of you have the certain breaking of failures in a certain product count. Okay, so here this is a new attribute, no, not attribute, sorry, new variable that I create as an object, and I activate it whenever the MU trigger this method. it will increase this variable by 1 and check if this variable is greater than 10, so greater or equal 10, and then you need to just equal 10, and then you set the defect into true, and then you set back the counter to 0. Otherwise, you set the defect to false. Okay, then now we can run it. F7 to say first. F7. Okay, then we run the simulation step by step, maybe. Okay, so we have the defect count is 1. Okay, and then now 2. 4, 5. The entry of that table row high is not MU. Yes. Okay. Sorry. Delete. Delete. Let's see. Okay. Okay. So maybe run again here. 5, 6, 7, 8, 9, 10, and then you will have the defect. Okay. But yep. So this is more about the defect of the machine, that you have the machine of the defect only 10%. Okay, of course you can also set the effect count for buffer red, for buffer yellow, for buffer blue, and the same logic add up to number, and then when it reaches to the threshold, and then you set the action move to the defect. Yep, so more or less it's the same as Mr. Bảo, but in the presentation is different. So I use the outside variable, and also count, but count for exactly how many times it happened. Okay, questions so far? Do you have any other solution, other way to do it?